After you thoroughly understood how to calculate the molar mass of molecules, we can use the relation number of mole equal to the mass over the molar mass to calculate the number of moles of molecules in a given sample, or mass equal to the number of mole multiplied by the molar mass to calculate the mass of the sample. And keep in your minds that the number of mole is expressed in moles, mass is expressed in grams, and the molar mass is expressed in grams per mole. Also remember that this relation can be used to calculate the number of moles of atoms, molecules, or ions. Now let's solve this example as a direct application on the rule. Calculate the number of moles present in 18 grams of water. You are given the molar mass of hydrogen as well as the molar mass of oxygen, so you can calculate the molar mass of H2O molecule, which is equal to the molar mass of oxygen plus the molar mass of hydrogen multiplied by 2, so as calculated previously, it's 18 grams per mole. Now you are asked about the number of moles. You already have the mass of water as well as the molar mass of water molecule, so substitute in this relation number of mole of water is equal to the mass of water over the molar mass. It's equal to 18 grams over 18 grams per mole. The answer is 1 mole. Move to another example. Oxalic acid C2H2O4 is a colorless solution that is widely spread in plants such as spinach. Given the molar mass of carbon, hydrogen, and oxygen, calculate the mass of oxalic acid present in 0.2 moles of C2H2O4. At first, we can calculate the molar mass of oxalic acid, which is equal to the molar mass of carbon multiplied by 2 since we have 2 carbon atoms, plus the molar mass of hydrogen multiplied by 2 since we have 2 hydrogen atoms, plus the molar mass of oxygen multiplied by 4. The answer is 90 grams per mole. Using the relation number of mole of oxalic acid equal to the mass of oxalic acid over the molar mass of oxalic acid, we can say that the mass of oxalic acid is equal to the number of mole multiplied by the molar mass. The number of mole of oxalic acid is already given, 0.2 moles. The molar mass is already calculated, 90 grams per mole, so the mass of oxalic acid is 18 grams. Now it's time to evaluate yourselves. A sample of 36 grams of glucose of molecular formula CxH2xOX contains 0.2 moles of such molecule. Given the molar mass of carbon, hydrogen, and oxygen, calculate the molar mass of glucose, then determine its molecular formula. Let's solve the first part of the question, which is to calculate the molar mass of glucose. You are given the number of moles of glucose, which is 0.2 moles, as well as the mass of a glucose sample, which is 36 grams. Now, using the relation number of mole of glucose equal to the mass of glucose over the molar mass of glucose, we can say that the molar mass of glucose is equal to the mass over the number of moles. Substitute the numbers, 36 over 0.2, the answer is 180 grams per mole. The second part of the question is to determine the molecular formula of glucose. As you can see, you are given the molecular formula in terms of X. So we can find the molar mass of glucose in terms of X. This is equal to the molar mass of carbon multiplied by X since we have X carbons, plus the molar mass of hydrogen multiplied by 2X since we have 2X hydrogens, plus the molar mass of oxygen multiplied by X since we have X oxygens. Now substitute the molar mass of each element in the formula. The answer is 30x grams per mole. In order to find the molecular formula of glucose, we have to find the value of X. Now we can say 30x is equal to 180, which is equal to the molar mass of glucose. Thus X is equal to 180 over 30, so X is equal to 6. Now substitute the value of X in the molecular formula of glucose, so the molecular formula of glucose will be C6H12O6. We also have another rule to calculate the number of moles of molecules. This is equal to the number of molecules, capital N, over Avogadro's constant Na. We're going to use this rule also to calculate the number of molecules, which is equal to the number of moles of molecules multiplied by Avogadro's constant. Now calculate the number of ethanol molecules C2H6O present in 10 moles of ethanol, given Avogadro's constant equal to 6.02 times 10 to the power 23 molecules per mole. In this example, you are asked to calculate the number of ethanol molecules. This means capital N. So you're going to use the relation number of mole of ethanol equal to the number of ethanol molecules over Avogadro's constant. So number of ethanol molecules is equal to N multiplied by Avogadro's constant. Substitute the numbers. Number of moles of ethanol is equal to 10 moles multiplied by Avogadro's constant, which is 6.02 times 10 to the power 23. The answer is 6.02 times 10 to the power 24 ethanol molecules. Another example, paracetamol is analgesic of molecular formula C8H9O2N. Given the molar mass of carbon, hydrogen, nitrogen, and oxygen, as well as Avogadro's constant. Calculate the mass of paracetamol sample that contains 12 times 10 to the power 23 paracetamol molecules. In this example, you are asked to calculate the mass of paracetamol sample. At first, you have to find the number of mole of paracetamol, which is equal to the number of paracetamol molecules over Avogadro's constant. The number of paracetamol molecule is given 12 times 10 to the power 23 molecules over Avogadro's constant, which is 6.02 times 10 to the power 23. The answer is 2 moles. Now, using the relation number of mole of paracetamol equal to the mass of paracetamol over the molar mass, we can find the mass of paracetamol, which is equal to the number of mole multiplied by the molar mass of paracetamol. The molar mass of paracetamol could be calculated from the molecular formula, which is equal to the molar mass of carbon multiplied by 8 plus the molar mass of hydrogen multiplied by 9 plus the molar mass of oxygen multiplied by 2 plus the molar mass of nitrogen. The answer is 151 grams per mole. Now the number of mole of paracetamol is already calculated. 2 multiplied by the molar mass of paracetamol, which is 151. The answer is 302 grams. Now, are you ready to solve this application? Calculate the number of moles and molecules in 25 grams of dinitrogen pentaoxide N2O5. In this application, you are given the mass of N2O5. From the molecular formula, you can find the molar mass, which is equal to 108 grams per mole. Now, using the relation, number of mole of N2O5 is equal to the mass of N2O5 over its molar mass. Substitute the numbers. 25 grams over 108 grams per mole. The answer is 0.231 moles. The second part of the question is to calculate the number of molecules present in 25 grams of N2O5. In order to find the number of molecules, we use the relation number of moles of N2O5 equal to the number of N2O5 molecules over Avogadro's constant. Now we can say number of N2O5 molecules equal to number of moles multiplied by Avogadro's constant. The number of mole is already calculated. Avogadro's constant is given. The answer is 1.39 times 10 to the power 23 N2O5 molecules.